Hi, I am Princess Meneses to give you a short but interesting discussion about Newton's laws of motion. For this discussion, we are to define force, describe the effects of force, state the Newton's laws of motion, define inertia, apply laws of motion in problem solving, define friction and its effects, state law of gravitation. So for this discussion, you will learn why or how things behave as they do. In simple words, force is a push or pull that causes a change in its velocity. It can start, stop, lift, pull down object to the ground, and change the direction of an object. It can also stretch an object to its limit and permanently deform it. Interestingly, it can make some object to float on and sink in water, as well as in air. So far, you have learned the different types of motion, like linear motion and non-linear motion. But why do things move? Why do things move faster than the other? We are now to discuss the laws of motion by Sir Isaac Newton. The first law, or the law of inertia, states that a body at rest will remain at rest and a body in motion will remain in motion at constant velocity unless acted upon by an unbalanced force. This is because of inertia. Inertia is the property of a body to resist a change in its state of motion. Another term that we need to consider is friction. It is another resistance to motion. It is the actual force that is exerted to the applied force. The second law, or the law of acceleration, states that an unbalanced force acting on a body produces acceleration. The acceleration is directly proportional to the force and inversely proportional with the mass of the body. Thus, we must remember that acceleration is equal to force over m. From here, we can say that force is equal to mass times acceleration. The unit for force is kilogram meter per second square or Newton. Even us, our bodies exert force. How? Are you aware of this formula? Where m is the mass of the body, g is the acceleration due to gravity, and w is our weight. The unit for weight is kilogram meter per second square. Thus, we can say that our weight is equal to force. How about the third law, or the law of interaction? When one body exerts a force on another body, the second exerts an equal force in the opposite direction of the first. Like for example, in mortar and pestle used for compounding, why does not the mortar break? Because mortar exerts equal force to the force exerted by the pestle. Another discovery by Sir Isaac Newton is the law of gravitation, which states that every particle of matter attracts every other particle. So he derived this formula. F is equal to G times m sub 1 times m sub 2 over r square, where m are the masses of the particles, r is the distance between the two particles, G is the gravitational constant, which is equal to 6.673 times 10 to the negative 11 Newton meter squared over kilogram squared. So, through this formula, we can determine the gravitational attraction between two objects. Let's have an example. Let us determine the gravitational attraction between these two objects. If this one has 2 kilograms and the other one is 2.5 kilograms, which are 1.5 meters apart. Let's substitute the values. Gravitational attraction is equal to 6.673 times 10 to the negative 11 Newton meter squared over kilogram squared multiplied by 2 kilograms times 2.5 kilograms over 1.5 meter square. The next, cancelling off the units. Then solve for the gravitational attraction, which is 1.48 times 10 to the negative 10 Newton. To summarize our discussion, we had force and its effects, 3 laws of motion. We need to remember that force is equal to mass times acceleration, and gravitational attraction.
Is an easy-to-use economical tablet hardness tester. It can operate as a constant speed or constant force tester and measure up to 99 samples per run. The test results are displayed via the LEDs. Any combination of thickness, hardness, and diameter can be tested. The tester has the capability of testing in newtons, kilopounds, and strongcops.
In pharmacy, tablets are sufficiently hard to resist breaking during normal handling and yet soft enough to disintegrate properly after swallowing. Special dedicated hardness testers are used to measure the degree of force required to break a tablet. A force of 4 kilograms is considered the minimum requirement for a satisfactory tablet.
The printout contains actual values as well as statistics.
For this topic, the value of inquisitiveness is learned. Asking how things go like this and like that, and also understanding how physics makes objects move. This is Princess Meneses of BS Pharmacy from Our Lady of Fatima University. Thank you.